It's wild, isn't it? All this talk about AI agents changing everything. But, like, how can we be sure they're actually as amazing as everyone says? He feels like we're just kind of trusting this stuff without really knowing what's going on.
Yeah, that's a totally fair point. It can be a real leap of faith, especially when so much of it still feels kind of mysterious.
Right, and that's exactly why we're diving into this today. We got to get past the hype and figure out how to build some actual trust in these AI systems.
Yeah.
And that's where this idea of, what was it again? Evaluation-driven development comes in.
ADD.
Right, exactly. Evaluation-driven development. It's like the key to making sure your AI isn't just smart, but also reliable and something you can actually count on.
Okay, EDD. So, why is this such a big deal? Well, whether you're building AI agents or just trying to keep up with all this tech, knowing how to evaluate them properly is like essential. It's the
Yeah.
difference between just hoping they'll work and actually knowing they will.
Yeah.
Right. And we want to make sure you're not just following along, but actually equipped to like build AI solutions that are transparent, dependable, and, ready to scale for real use cases.
And to do that, we've been digging into some really cool stuff. We've got transcripts from Arise AI meetups, some of their YouTube videos, and articles from their website. They've got a lot of practical, hands-on advice for evaluating AI agents.
Yeah, they do a really good job of breaking it down.
So our goal here is to give you the tools to understand how to assess and actually improve the performance of these AI agents. No more buzzwords, just clear, actionable steps. So ready to jump in?
Absolutely. Let's get started.
Okay, cool. So first things first, what's the biggest hurdle when it comes to evaluating these agents and those big language models everyone's talking about?
Well, the challenge is that unlike traditional software, it's hard to like pinpoint exactly what's happening inside an AI agent. It's not always clear how it arrived at a particular output.
It's kind of a black box, isn't it?
Exactly. And that makes it really tricky to like figure out what's working and what's not. You make a tweak to the prompt or
Mm.
change the model, but it's tough to say for sure whether that actually made things better.
And then there's the whole issue of those crazy AI blunders we've all seen, right?
Mhm.
Like the one where the AI told someone to put glue on a pizza,
Yeah.
or the one that tried to sell a car for $1. Those are pretty memorable, to say the least.
Yeah, and those examples show just how important it is to have robust evaluation processes because when AI goes wrong, it can go really wrong.
No kidding.
Wow.
So how do we start to address this, like lack of visibility? How do we peek inside the black box?
Well, this is where the concept of observability comes in. And companies like Arise AI are really pushing for better tools and methods to give us more insight into what's going on within these agents. It's about tracing the information flow, understanding how decisions are being made, and tracking key performance indicators over time.
So it's about shining a light on those internal processes. And speaking of light, that leads us nicely to, what was it called? Evaluation-driven development, or EDD.
EDD, yep. It's all about making evaluation the heart of your AI development process.
Okay, break it down for me. What does EDD actually look like in practice?
So imagine it like you're building a house, right? With EDD, you don't just start throwing bricks together and hope for the best. You start with a blueprint, a clear set of goals for what you want to achieve.
So you're saying you need to define what success looks like from the very beginning.
Exactly. You establish measurable performance targets, and then every step you take in developing your agent is guided by how well it's meeting those targets.
Okay, I'm starting to see the logic here. So what are the actual steps involved in this EDD cycle?
It's an ongoing process of, building, testing, learning, and refining. It starts with what we call tracing, which is basically carefully recording every single action your agent takes.
Kind of like leaving a trail of breadcrumbs.
Yeah, exactly. And then you move into development, where you're actually making changes to your prompts, the models, or the tools the agent is using. Then comes experimentation, trying out different versions or configurations of your agent. And that leads to formal testing against a predefined set of test cases.
Test cases. So we're talking about like a series of challenges or scenarios that we throw at the AI to see how it performs.
Right. And if your agent passes those tests, then you can move on to launching it. But even after launch, the cycle continues. You monitor how it's performing in the real world, gather insights from that usage, and then use those insights to further refine and improve your agent.
So it's not just about getting it to work. It's about continuously making it better.
That's the idea. You're always learning and adapting.
Now, you mentioned these test cases. What makes a good set of test cases? Like, what should we be including?
Well, it depends on the specific capabilities of your AI agent, but the goal is to create a comprehensive suite of tests that cover all the different ways your agent might be used.
So if we're talking about a chatbot, for example, what kind of tests would we want to include?
You'd want to include queries that trigger specific functions. Like if it's a travel agent, you'd test booking flights and finding hotels. You'd also want to test its general knowledge and even throw in some off-topic questions to see how it handles those.
That makes sense. Put it through its paces.
Hmm.
Now, what about when we have more complex agents with, lots of different components working together? How do we evaluate those?
Right, so for those more intricate workflows, you can't just look at the final output. You need to break it down into smaller chunks and evaluate each step along the way.
Okay, so we zoom in and look at each part of the process. And how do we actually do that evaluation?
There are two main approaches. One is to compare the output at each step to a known correct output. We call that ground truth.
Ground truth. So it's like having the answer key.
Precisely. And this works really well for tasks where you have a clear expectation of what the output should be, like routing a request to the right function or extracting specific information from a text.
But what about when the answer isn't so clear-cut, or when there might be multiple valid responses?
You're right, and that's where the second approach comes in. We can actually use another LLM as a kind of judge to assess the output.
Whoa, hold on. An AI judging another AI, that sounds pretty wild.
It is. We call it LLM as a judge, or LAGE. And it's incredibly useful when you don't have a definitive ground truth, or when you're evaluating more subjective qualities like, is the response truthful? Is it relevant to the query?
So we're essentially using one AI to grade the homework of another AI.
Yeah, kind of like that.
But how do we know that the judge AI is giving fair grades?
That's where benchmarks and golden data sets come in. These data sets contain examples that have been carefully labeled by humans. So you can test your Judge LLM against those examples and see how well it aligns with human judgments.
Okay, so we're checking the checker. Now, what kind of feedback did this judge LLM give? Is it just a simple pass or fail?
It can be. We often use categorical evaluations, which are either binary, like correct or incorrect, or multi-class, where you have several predefined categories.
Got it. So not just a thumbs up or thumbs down, but a more nuanced assessment. And you mentioned earlier that it's good to have some explanation of why the judge LM gave a particular score, right?
Absolutely. Explainability is really important. We want to know the reasoning behind the judgment. You know, did the agent hallucinate information? Was the response off topic? Understanding why helps us improve the agent's performance.
This is all starting to make a lot of sense. But can we see some real-world examples of how this Logier approach is being used?
Sure, let's think about RAGI, retrieval augmented generation. This is where you retrieve information from a knowledge base and use it to generate a response. We can use Lage to check if the retrieved information is actually relevant to the user's query, and we can also use it to assess whether the generated response is faithful to the source material.
So we're checking for accuracy and relevance. And what about evaluating the entire agent as a whole?
Yeah, so with Lage, we can assess whether the agent chose the right tool, extracted the right parameters, and followed a logical sequence of steps to reach its conclusion. And there are even libraries like Arise Phoenix that have pre-built Lage templates for common evaluation scenarios, which can save a ton of time.
That sounds incredibly helpful. But what if I need to evaluate something very specific, something those templates don't cover?
You can always build your own custom Lage evaluations. You start by clearly defining what you want to measure. Then you create a golden data set with labeled examples. And then you craft an evaluation prompt for your Judge LLM, telling it exactly what to look for. It takes some work, but it gives you a lot of flexibility.
Okay, so we've covered the evaluation part of EDD, but how does all of this actually play out in practice?
Well, Arise AI has a great YouTube video where they walk through building and improving a travel agent chatbot using EDD. They show how to trace the agent's actions, build data sets for testing, and experiment with different prompts and models.
Sounds like a really practical demonstration.
It is, and they highlight the iterative nature of EDD. You make a change, you test it, you evaluate the results, and then you make further refinements. It's all about continuous improvement.
And even after you've deployed your agent, the evaluation doesn't stop, right?
Right. You can still use LACJ to monitor your agent's performance in the real world and identify any emerging issues. And it's also valuable to have human experts review some of the Judge LM's assessments to ensure accuracy and provide feedback.
So even in production, we're still learning and refining. Now, one thing I'm curious about is the cost and speed of all these LLM evaluations. Are those concerns?
Definitely. Running LLM evaluations at scale can be resource intensive. But there are ways to manage that. You can choose a judge LLM that's appropriate for the task, you can sample your data, and you can prioritize which metrics are most important for your specific application.
Okay, so be strategic about your evaluations.
Yeah.
Makes sense. Now, our sources also touched on this idea of going beyond basic RAG to more advanced agentic strategies, particularly with Llama Index. What's that all about?
So RAG is great, but it does have its limitations. It's usually single turn, the query understanding is limited, it doesn't use external tools, and it doesn't really have a memory. Agentic strategies aim to overcome those limitations.
So how do they do that? What makes them more advanced?
They can engage in multi-turn conversations, use RAG as just one of many tools, and play reflection for error correction, and incorporate memory to retain information from past interactions. Frameworks like Llama Index provide a lot of built-in tools for building these more capable agents.
So we're giving the AI more autonomy and a wider range of capabilities.
Exactly.
Can you give us a quick overview of some of these specific strategies and the types of reasoning they might use?
Sure. One strategy is routing, where the agent decides which tool is best for a given task. Then there's memory, which allows the agent to remember previous interactions. And we have one-hop query planning, where the agent breaks down complex queries into simpler steps. And of course, there's tool use, where the agent can call external functions or APIs. In terms of reasoning, there's sequential reasoning like react or chain of thought, where the agent thinks step by step. Then there's DAG-based planning, which is more like a flowchart of steps. And finally, there's tree-based search, where the agent explores multiple paths to a solution. It's like sequential reasoning is following a recipe, DAG-based planning is mapping out a project, and tree-based search is exploring different options to make a decision.
Wow, so we're really pushing the boundaries of what AI can do.
We are. And this whole deep dive into evaluation-driven development has given us a framework for building more robust and trustworthy systems.
So for our listeners, the takeaway here is that evaluation is crucial for building AI you can rely on. Whether you're building AI agents or just trying to understand them better, having a solid grasp of EDD and the tools we've discussed is essential.
Yeah, it's all about moving from hope to confidence. And remember, there are resources out there like Arise AI's Phoenix Library and Llama Index that can help you put these concepts into practice.
And as a final thought, I want to leave you with this. How will a rigorous approach to evaluation be the key to unlocking the full potential of AI agents? Because I truly believe that we can build AI that we can trust, we can unlock some truly incredible possibilities. That's it for this deep dive. Thanks for joining us.